And if there's any other questions along the way, feel free to ask. Yep. So let me go through question number 11. Okay. So here you got a probability distribution table. Yep. So let me just start by quizzing you guys. What sort of probability are we dealing with? I'll give you two choices. We're either dealing with theoretical probability or experimental probability. Which are the two when we've got a proper distribution table?
Would this be the theoretical?
Okay. So in your understanding, what is theoretical probability?
From what I understand, it's just doing the maths behind doing the maths to find the probability of something.
That's right. So, so it's essentially theoretical probability is equally distributing the probability of outcomes based on the number of choices that you have, right? So if you've got a six-sided die, right, each choice or each possibility will have an equal probability in terms of what you roll, what the outcome will be when you roll it. Okay.
Mm-hmm. Yep.
Probability. What would experimental probability be? Anyone want to have a guess?
That'd be testing.
Yeah. So you roll it a number of times, and the number of times that a specific outcome occurs will be its experimental probability, or the other word we use is its relative frequency. In this situation, what's more likely to be the case? Theoretical probability or experimental probability?
Probably the theoretical, wouldn't it?
I'm feeling experimental.
Yeah, experimental probability, right? You got a die, right? See if you can follow, Jackson. You got a die, okay, and you've got 6 outcomes. You got 1, 2, 3, 4, 5, 6. What's the theoretical probability of rolling a 1?
Oh, yep. Okay, that makes more sense. Yep.
Yeah. The theoretical probability would be 1 out of 6, right? A 2 would be 1 out of 6. A 3 would be 1. Each of these would be 1 out of 6. However, that's not what we have here. We have a situation where some of the outcomes are more frequently occurring than others, okay? Which is probably more reflective of what you'd get in the real world when you kind of bring randomness into the equation. Okay, so just from your observation, can anyone tell me how many times you think this dice was rolled?
10 maybe?
10. Why would you say 10?
Because most of the fractions are out of 10.
Yeah, the denominator kind of gives it away, doesn't it? They're all 10. Now, why would this one be 5?
They're just simplified.
Yeah, because they're simplified versions of it. Okay, so let's now look at the notation. What do you think P of X equals to 2 means? Right, I'll give you a hint. The P stands for the probability of what? Of your outcome equaling
Yeah, so it'd be the 3/10. Got it?
Yes.
Okay.
Got it? So your answer for this one would be 3 out of 10. Got it? So the way we read this is that we're dealing with the probability of your outcome equaling 2. Got it?
Yeah.
Jackson, given that you're the one that asked this question, what would, if you had to describe in words or translate into words what this notation represents, what would you say?
I'd say that would be the probability of X equaling either 1, 2, or 3.
Yes. So it's the probability of your outcome being any number less than 4.
Mm-hmm.
Got it? Okay.
Yeah.
Cameron? Yep. This one here?
That one would be 2, 3, 4, 5, and 6 added up.
Yeah, so that would be your
Oh.
sample space. Yeah, your sample
Mm.
space would be 2, 3, 4, or 2, 3, 4, 5, or 6. Got it?
Yeah.
Yep. So in words, decoding this notation using these words, how would you translate that notation? So this would be the
Probability of something occurring
yeah.
that is greater or equal to 2.
Yes, got it. So it would be the probability, right, of your outcome being greater than or equal to 2. Does that make sense?
Yeah.
Okay. Artie, what would this one be?
Which one?
D.
The probability of the outcome being
Mhm.
less than or equal to 6 or greater than or equal to 4.
Yeah. Okay. So between 4 and 6, including 4 and 6.
Yeah.
Okay. Yeah. Awesome. Cool. Now, all right. So let's have a look. Jackson, can you do E? Cameron, can you do D? And Artie, can you do A, B, and C? And we'll compare our answers.
Sounds good.
Okay, so just do them on a piece of paper, and then we'll go through it. Okay, in the meantime, let me just rub out some of this stuff because it's hard to read, isn't it?
The answer to A is already up there, though.
Oh, yes, that's right. So what's the answer for A?
3 out of 10.
Yep, 3 out of 10. Okay, B?
For B, 3 out of 5.
So this would be 2 plus 3 plus 1. Is that right?
Yeah.
2 plus 3 plus 1 is 3 out of 5. Yeah, 6 out of 10, which is also equal to 3 out of 5. Good. C?
C, I got 9 out of 10.
Yes, 9 out of 10. Now, let me just go through something else. I'm just going to go on a bit of a detour. Okay, this expression has a sample space of which numbers? Okay, Jackson, do you know what I'm talking about when I say sample space?
Sample space would be anything greater than or equal to 2.
Yeah. So what would be the set of the sample space? What numbers would that include?
It'll be 2, 3, 4, 5, and 6.
2, 3, 4, 5, and 6. Now, what number does it not include?
My 1.
1. Okay. So another way of writing this in terms of its complementary form, right? Do you know complementary events?
Yep.
Okay. Would be, so what would be the complementary event of 2, 3, 4, 5, and 6?
1 minus when x equals 1.
Yep. So when x equals 1 is the complementary event.
Right.
So the way we show that this is a complementary event, or that this is a complementary event to this, is we put like a little hat over the top. Got it?
Yep.
See that hat? It means anything that's not x equals to 1.
Yeah, that makes sense.
Got it? So that and that are the same. Yep.
Oh, yeah. Okay.
Yeah.
Yeah, that makes sense.
Okay. All right. So D. Who's doing D?
That was me.
Yeah, that was you. All right. Let's do D.
So it's pretty much 4, 5, and 6, which is 4/10, which simplifies down to 2/5.
Yes, that's right. So P of 4 X or X. It's a capital X, isn't it? And 6 is equal to 4 out of 10, which is 2 out of 5. Got it?
Yeah.
Yep. And who's last? Cameron.
Yeah. I got 7 out of 10.
Yes, that's right. Okay. So what would be a way of writing the complementary, the same thing in a complementary way?
The probability.
You know, there's no that. That one doesn't exist. Yeah. Okay. Yep.
Um, 5 or larger than 4.
Yes. Yeah. You
Or
can either write
5.
5 or 5 or 6. Yep. Or you can go, yeah, I like the way you did it better. Because it's more mathematical. Greater than 4. Yeah. That's what you wrote, isn't it? Okay. And then
Yeah.
bar over the top. And the answer is 7 over 10. Is that right?
Yeah.
Cool. All right. Yeah, awesome. So in terms of the actual mathematics is not hard. It's just getting used to the notation. Yeah.
Yeah, that makes a lot more sense.
Okay. Good. All right. So that's question 11 done. Keep scrolling through the questions, or keep just scanning your eye over the questions. And if there's any other questions that you want me to answer, we can go through it